want to go?
Yeah, you're good. Whoa, how did that happen, Ethan?
Inertia.
Inertia?
Inertia? What's that? Well, the way we think of inertia is that force equals mass times acceleration,
Which is a change to, a resistance to change in velocity or acceleration. However, in this scenario, we're talking about moment of inertia. What is moment of inertia? Moment of inertia is essentially the resistance to a change in rotational, like acceleration or velocity. So essentially, it's how hard to spin something.
and the equation for it is you're going to have m being the mass of the object, r squared. R squared meaning r is how far away it is from the axis point, or the rotation.
Say, Ethan, why does the moment of inertia matter?
The moment of inertia matters because it determines how difficult it is for an object to change.
Change what, Ethan?
It's angular momentum.
Say, Alex, how do you decrease or increase the moment of inertia?
Well, you'd have to change the R value.
If you increase the R value, what will happen?
The moment of inertia will increase. And if you decrease it, the moment of inertia will decrease.
Now, what was the inertia that Ethan was talking about? This inertia is called the moment of inertia. And essentially, the equation, the general equation, is I equals mr squared. M being the mass, and R being the distance that the mass is from the fulcrum, or rotational point. So in the example we just had, here's the first wheel. And you can see the masses are evenly distributed far out from the radii. However, the second wheel, the masses are more closely packed to the fulcrum, right? So, therefore, this has a larger R value because it's farther from the fulcrum. Now, keep in mind, the moment of inertia is essentially a measure of resistance to a change in angular velocity or acceleration. So, as this has these masses a larger distance from the fulcrum, that means that the R value is going to be higher, which means they're going to have a higher value of the moment of inertia, which means that they are going to have more resistance to a change in rotation. This is why it moves slower, because it's resisting that change. It's resisting a change in speed. However, this is more tightly packed. It's more close to the fulcrum. Therefore, it's going to have less I value compared to this because of the lower R value. And since it has a lower I value, that means it's not going to be as resistant to change, which is why it's able to speed up as fast as it does. So, as you see, closer to the fulcrum, less inertia. Farther, it has more momentum. He's carrying a 45-pound weight. However, what we're going to change is we're going to spin him around, and first he's going to keep the weight tucked in, and then he's going to extend the weight. And we're going to see how his speed differs based on how far he extends the weight from his body. Here's the example of the close. Ready, Alex? This is the example with it farther extended from his body. As you can see from this example, when you extend the weight out farther from your body, it's going to make him spin slower. But when he tucked it in, it made him spin faster. Why is that? Well, it goes back to the thing we were talking about on the
Since
white.
the R values are changing, the angular acceleration would also be changing because of the equation I equals mr squared.
How would you find the moment of inertia of this ball?
Would you use the equation I equals mr squared?
That's right, you would use the equation I equals m. What are some of the values we know, Alex?
Well, the M would be 2 kilograms,
Mm.
and the R would be 1.5 meters.
The R would be 1.5 meters. Values are 2 and 1.5. So it would be 2 times 1.5 squared, correct?
Yes.
What does your calculator get when you plug in those values?
I got 4.5.
4.5.
But what are the units, Mr. Sean?
Ah, the units. Good thing you asked. The answer not is selfish. It's not just 4.5. There has to be units, right? What is the unit of the mass that we use, as you can see in the ball?
Be kilograms.
Kilograms. Good. And we're multiplying it by what?
Radius squared. So it would be
Which is
meter squared.
meter squared. Perfect. So our final answer is going to be 4.5 kilograms meters squared. And this is a measure of the moment of inertia. inertia, how much it's going to resist.
So depending on the object you're using, there will be a different equation for each. For a solid sphere, it would be 2/5 mr squared. For a solid cylinder, it would be 1/4 mr squared plus 1/12 ml squared. And for a rod about an end, it will be 1/3 ml squared.
So you use these as 3D objects?
Yes.
Ethan is carrying the weights right now, but he's here in spirit, and we just want to say
Thank you for watching.
thank you for watching.
Who's gonna lift the boats?